So this lesson looks at a new idea called a factorial. So let's go ahead and look at this definition. It's a new operation, but it has some funky notation. So factorials are just products of numbers, but this operation is indicated by an exclamation mark. So if you see something like this 4 exclamation point, that is not an excited for. However, I will not be upset if that's how you think of it. Rather, that indicates 4 factorial. So 4 factorial means the same thing as taking 4 times 3 times 2 times 1, which equals 24. So super tempting to read that as 4, but unfortunately it's just 4 times 3 times 2 times 1. Again, I think it's fine to say it as an excited for in your head, bring a little joy to your life and your math work, but it's super important to understand what that means. So in the general case, n factorial means the product of all the whole numbers from n down to 1, where each successive factor is 1 less than the previous factor. So we can see that that is kind of detailed out here in this definition for us. Notice that fits perfectly that description that we opened these notes with, right? If I write 4 factorial, I'm really looking at 4 times 4 minus 1 times 4 minus 2 times 4 minus 3. And then there I'm actually going to stop because notice if I do 4 minus 4, that will, 4 minus 4, that will give me 0, and that would cause this whole sum to be 0. So you want to stop this multiplication at the factor of 1. So if I look at all of these factors, I can see that this is really just 4 times 4 minus 1, which is 3, times 4 minus 2, which is 2, times 4 minus 3, which is 1, which is what we saw above. And we saw that that is equal to 24. Okay, so to get used to this notation, we're going to go ahead and look at a couple examples of going into factorial form from this extended product. So I'll notice that in example 1, we're starting with 6 and we're multiplying all products down to 1. So in factorial form, 6 times 5 times 4 times 3 times 2 times 1 is simply 6 factorial. Similarly, in example 2, we see that we're starting at the value of 3 and we're multiplying decreasing factors by 1 all the way down to 1. So we can call that 3 factorial. Okay. In example 3, we flip the process here, right? We're given 5 factorial, so we're given the number that we're supposed to calculate. So 5 factorial is the product of 5 and all the factors decreased by 1 until 1 itself. So 5 times 4 times 3 times 2 times 1. And when we're asked to evaluate this, we actually want to compute that product. So if we grab a calculator or maybe think through this for a second, we'll see that it is 120. Example 4 has a couple things going on. Notice we have first 4 factorial, so we should probably figure out what 4 factorial is. And then we also have 0 factorial, and we'll talk about that here in a second. So 4 factorial we saw from above is 24, but it's worth maybe reminding ourselves that that is the product of 4 times 3 times 2 times 1, and then we're going to add to that 0 factorial. And this is something I kind of skimmed over, well, kind of skipped actually in the introductory conversation here, but you can see in your guided notes that it is a fact that 0 factorial is equal to 1. Okay, that's something you can definitely explore with some Google searches, or we can chat about it in office hours. But if you want to just accept that as true, that is totally fine with me. Okay, so 0 factorial, it's really tempting to say that it's 0, but it is actually the quantity of 1. Okay, so that will help us simplify example 4. So we have that product 4 times 3 times 2 times 1 coming from 4 factorial. That will give us 24. And then we will add to that 0 factorial, which is 1. And we find then that 4 factorial plus 0 factorial is just 25. Okay, so a couple operations happening there. In example 5, we have the quotient of 2 factorials. So here I think it's really helpful, especially as you're just starting to get used to this idea. I think it's helpful to write out each factorial. So to write out each product. Okay, so 6 factorial, hopefully we're comfortable with saying that that is 6 times 5 times 4 times 3 times 2 times 1. And we're going to divide that by 4 factorial, which at this point we probably will be quick to say that that's just 24. But I'm actually going to go ahead and write out that product. And you'll hopefully see why in a second. So 4 factorial is 4 times 3 times 2 times 1. So something really convenient is happening right now, right? We have a collection of factors in the numerator and a collection of factors in the denominator. And since all of the pieces of the numerator, all those factors, they're related through multiplication, and the same is happening in the denominator. So what we get to do is maybe one of our most favorite things in math. We get to cancel out those common factors, right? We have common factors in the numerator and denominator, and doing so leaves us with the fact that 6 factorial divided by 4 factorial is actually just 6 times 5, which we know pretty simply is 30. Okay, so we can say that 6 factorial over 4 factorial is equal to 30. All right, so similarly here in number 6, we have another quotient of 2 products, another quotient of some, I guess they are products, but factorials was how we're kind of seeing these initially. So we have 3 factorial divided by 0 factorial. It's really tempting here to say that we can't do this, right? If we mistake 0 factorial to be 0, we might be tempted to say that we can't do this division, that we can't divide by 0. But remember, we've been told that 0 factorial is actually just 1. So we have 3 factorial, which is 3 times 2 times 1 divided by 1. We have a kind of a low stakes cancellation happening here that you guys are welcome to do, or you can recognize that 3 times 2 times 1 is just 6, and then 6 divided by 1 is 6. So here we have that 3 factorial over 0 factorial is just the value of 6. All right, so things get a little bit more interesting in 7. We have a product of 2 factorials in the denominator, but kind of the approach is going to stay the same here, right? We're going to list out the factors of 7 factorial, the factors that make up 2 factorial, and the factors that make up 5 factorial, and we're going to see what simplification can happen between the common factors of the numerator and the denominator. So using our definition of factorial and our understanding thus far, we're going to be able to rewrite 7 factorial as 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and then we will have our 2 factorial, which is kind of short and sweet, right? That's just 2 times 1. If you don't want to write the 1 at the end, if you just want to recognize that 2 factorial is 2, that's totally fine. But I think just right now with this introductory piece, right, we're still trying to wrap our head around this idea of a factorial. I think I'm going to continue to write all of the factors down to 1, including 1. But then I have to multiply this by 5 factorial. So 5 factorial will be 5 times 4 times 3 times 2 times 1. And again, we're in that situation where we have a collection of factors in the numerator and a collection of factors in the denominator, and we can start reducing or canceling those common factors, numerator to denominator. So right away I see that the 5 factorial here cancels with a majority of the 7 factorial, right? There's a lot of commonalities there. They share 5 factors. So that cancellation leaves us with 7 times 6 divided by 2 times 1, but I'm going to choose to go ahead and write that just as 2. And there's a couple ways to approach this from here, right? We might want to compute 7 times 6 and then divide that product by 2, or we may recognize that it's actually simpler to divide the 2 into 6. So 2 divides into 6 3 times, and this is actually just 7 times 3, which we know to be 21. So all of this work goes to say that this kind of crazy looking expression at the beginning that we had, 7 factorial divided by 2 factorial times 5 factorial, is equal to 21. All right, we have one last example for this video. Example 8, evaluate 100 factorial over 98 factorial. So I'm going to start this process in a very similar way, but because I value my time, and I feel like you probably have better things to do than write out all 100 factors of 100 factorial, I'm going to kind of be smart about what I do here. So I know that 100 factorial is definitely 100 times 99 times 98 times 97, and I think we get the idea, right? We're going to decrease all those factors all the way down to 1, but I do not recommend actually writing that out. So if you'll notice, we're about to collect a lot of common factors in the denominator when we expand 98 factorial. So 98 factorial is 98 times 97 times, and I'm going to go ahead and repeat what I kind of mirror what I have in the numerator. I'm going to continue that just in my head saying dot, 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 right? I know that that's going to be 96 times 95 times 94, so on and so forth. Because of that nature of the multiplication, I know that the 98 from the denominator and the numerator reduce each other, as does the 97 and the 97. And then all of these trailing factors in the denominator after 97 are present in the numerator, right? We have the same trailing factors there, so they will all cancel. Okay, so what this does is it just leaves us with the product of 100 times 99. And that's a much simpler thing to calculate than write out all factors of 100 factorial and all factors of 98 factorial. Okay, so that multiplication just gives us the value 9,900. So this tells us that 100 factorial over 98 factorial is equal to 9,900. All right, at this point, I would go ahead and try questions 1 through 4, making sure that you're checking your work against the answer key, reaching out to me via email or in office hours if you have any questions about those. And in the next video, I'll take you guys through examples 9 and 10.